Beth.
And I'm Beth.
Welcome to Physics with Beth and Beth. Hello and welcome to Physics with Beth and Beth. I'm Beth. We're in this AP Physics 1, Unit 8, Fluids. This is our last unit. You're almost there. You've done great. Hang in there. All right. Today we're going to be talking about Pascal's principle. It's a pressure that's applied to a confined, incompressible fluid is transmitted equally in all directions. Okay, as my colleague Beth likes to say, that's a big old word salad. So let's try to figure out what that exactly means. But it's a pressure applied to a confined, incompressible fluid. And that pressure will be transmitted equally in all directions in that fluid. All right, now we got to remind ourselves, which we have other videos before this one, of what pressure is. And pressure is force divided by area. All right, now I always like to tell my students it's about shoes, tennis shoes versus a high heel stiletto type shoe, because that kind of helps you remember. If I talk about a 100-kilogram woman who is standing on tennis shoes, well, that's a pretty large area. So this is a pretty large area, and it keeps the pressure on your feet, on the balls of your feet, pretty minimal, a tennis shoe. However, if you put on a stiletto high heel shoe, you know what I'm talking about, right? Where we have the little, let's do the high heel, and it comes all the way down, and there's just a little bitty part that you stand on the shoe. And actually that little stiletto is really thin. All right, you have reduced your area tremendously in that high heel stiletto shoe. So if your area goes down, then your pressure goes way up, right? There's a lot less area than if you had a tennis shoe that had the whole sole across for that force to be applied. Same person, say a 100-pound person, we're in English units, but a 100-pound person. And so what happens is, believe it or not, 75% more pressure on the balls of your feet on average on a stiletto high heel than on a tennis shoe. So I'll let you ponder that and what that might do to the bones of your feet, on the balls of your feet, but they are so cute. They're hard to resist. But anyway, that's what pressure is, okay? So it's that force divided by area. Okay, so Pascal just says, hey, you apply this pressure to confined compressible fluid, and it's actually going to be equally distributed throughout that fluid. So the best place to see this is on a hydraulic system. Now, if like I'm in a car repair shop, an oil change place, they're going to put your car on some sort of a little plate, and they're going to apply a force over here to this piston. And then that pressure is going to be equally distributed because this is an incompressible fluid. And then there's going to be a force upward because of that that's going to lift this plate and lift the car. Now, I know that my car is way out of proportion to scale here, and it's terrible. My colleague Beth is the artist, not myself. But anyway, that's what a hydraulic system is. It comprises of two pistons and compressible fluid in between. All right, you push on one side, that pressure is equally distributed, and then it pushes the car up. So that means pressure 1 on this side has to equal pressure 2 on this side, because that's what Pascal says. That pressure is going to be equally distributed. So, and we know pressure equals force over area. So we say, hey, P1 equals P2, the left side versus the right side. We know pressure is force over area. So my force 1 and this area of this piston is going to be equal to the force 2 that I'm going to get and gain from that pressure being distributed over the area of that piston, the second piston on the right. All right, now if I wanted to say, hey, I need to know how much force, or how the weight, well, let me try that again. I want to know how big of a weight of a car that I can lift on this plate. All right, well then you just rearrange this. So we would have the force 1 and the area 1 of that piston times the area of the second piston over here is going to equal that force, and you can figure out how much weight that you can handle on that plate. how big of a car. Can a Hummer set on it and lift it fine? Or a huge kind of like tow truck? Or is it only smaller cars, right? So you could figure that out. And by the way, I should tell you the force, of course, is measured in newtons. Area is going to be measured in meters squared. And then that's really all we have. Okay, we're almost there. We're almost to the end. Let's just do a quick problem, make sure we can understand it. A hair salon chair, by the way, is a hydraulic system, believe it or not. So you see them probably all the time in your daily life. Hydraulic systems that you may just not realize, but a salon chair is one. So I've got a hairstylist that applies 125 Newton force to a hydraulic piston, which is the foot pedal, all right, with an area of 0.01 meters per second. And that is our area, 0.01 meters squared. I said per second. Let me get that right. 0.01 meters squared, sorry, on a salon chair. If the 5 kilogram chair is attached to another piston, which is going to be bigger, with an area of 0.1 meters squared, how much mass can the chair raise? All right, here we go. We know that P1 equals P2 because of Pascal's principle. We know F1 over the force 1 divided by the area 1 of that piston is going to equal the second force, the force we're going to gain to lift that person in the chair, divided by the area of that second piston. All right, now I just am going to solve because that's what I want. I want how much mass can the chair raise? But we've got to find force first. And then we know if we find force that that's going to be mg, right? All right, so here we go. I'm going to multiply. I have F1. I'm going to come over here. I have F1 times A1. So my force 1 divided by that area of the first piston times my area of my second piston is going to equal that force that I'm looking for. Once I find that, I can divide by little g to get my mass. All right, so here we go. Force 1 is 125. The area of that first piston, that's the little foot pedal, so it's smaller. It's 0.01, and that's going to be multiplied by the area of the second piston, which is the chair, which is bigger, which is going to be 0.1. And that's going to be that force. And that force comes out to be 1,250 newtons, but they didn't ask for the weight. If they'd said how much weight can the chair raise, then you're done because weight is a force. All right, but they asked for the mass that the chair can raise, so now we have to do that little extra step. All right, and force equals mg. My force is, I'm looking for mass, so that's going to be force divided by little g is m. So that is 1250 divided by 9.81. I know on the AP exam you're going to want to use 10 for simplicity. It's just the engineer in me. I can't let go of 3 sig figs. So anyway, but you could use 10 and you will be just fine on the AP exam. Always you can use 10 for little g. All right, and then when I do that, divide by 9.81, my mass is going to be 122.4 kilograms. And I have my mass. Again, if they'd asked for weight, you would have been done here. Okay, that's it. That's Pascal's principle. Pressure applied to confined incompressible fluid is transmitted equally in all directions. I hope this reduces some of the pressure for you understanding this unit. If you liked, pun intended, if you liked this video, please give us a thumbs up, subscribe if you haven't already, share with your friends if they need help, and you've got this. The AP exam is coming, but you've got this. You can do it. Thank you for watching and happy physicsing.